Uh, Good morning, and today's topic is linear equations in two variables. When you have a pair of linear equations, when you solve them, of course, you get the points of intersection. That's the topic we have got today. Pairs of linear equations. Sometimes we call it a system also, like pairs of linear equations. And you can be precise in saying that in two variables, okay, x and y, in two variables. So a linear equation generally is represented, it's a first degree equation. So you write a1x plus b1y, okay, plus c1 is equal to 0, or you can write is equal to c1. Better you write plus c1 is equal to 0. Makes no difference. Constant can be the other side also. So a1x plus b1y plus c1 is equal to 0, where a1, b1 and c1 are some numbers, like usually integers, they can be any real numbers. So I write here a1, b1 and c1. They belong to the set of, say, some real numbers, like. Okay, so this is a linear equation. There are absolutely no conditions about a1, b1, c1. There are some real numbers. This is called a linear equation for a specific reason. Why do you call it a linear equation? And if you plot this equation on the graph paper, okay, and plotting the equation gives a line. That's why this is called a linear equation. Okay, if you take an equation of this kind and try to take some points which satisfy that condition, and then if you plot all the points, they lie on a single line. I just give you one example to substantiate my claim. Let us say there is an equation like this. Okay, 7 can be this side or that side. Let us take some points which satisfy this condition. You need, say, 1 or 2 points and 2 points to draw a line, and the third point may be for verification. So you can choose some x and y arbitrarily, and let us take some 4 points which satisfy this condition. Now if I say I take in place of x1, 2 1s are 2 and 5 can give me 7. So if I choose x as 1, y will be 5. If I take in place of x, say 2, arbitrarily chosen, 2 times 2 is 4, 4 plus 3 will be 7. So if x is 2, y will be 3. I take 3, 2 times 3 is 6, and this will be 1. So if x is 3, y will be 1. I can take even 0, what's wrong in that? So if x is 0, 2 times 0 is 0, y will be all the 7. So I have taken 4 ordered pairs here, 1, 5, 2, 3, 3, 1, 0, 7. So what I want to do now is, I just want to take a graph paper, draw my reference lines x-axis and y-axis, and try to plot these points. That is what my contention is all about. So this is my x-axis, and here I have my y-axis. They should be perpendicular to each other. There is nothing like a midpoint, because every point is a midpoint on a line. So not necessary that you have to measure, because the graph paper is limited, but the plane is not limited. And therefore anywhere you can draw this y-axis. Absolutely no problem, of course. See, you have here 1, 2, 3, 4 and 5. These are the positive integers you are taking on the right side of a y-axis, like 3, 4, 5. And you can go along y-axis. Let us say 0 is here, or this is where you start. Say 1, 2, 3, 4, 5. I'm marking a few points, of course. 4, 5. Similarly, when you go on the left side of x, this is a negative x-axis, this is a negative y-axis. I want to plot these points 1, 5, 1, 5. It is somewhere here. Okay, 1, 5. Then I have 2 comma 3. I just 2 and this is 3. 2 comma 3. And 0 comma 7 and 3 comma 1. 3 comma 1 is here. 3 comma 1. And 0 comma 7, of course. 0 and 7. You must go 0 and you must go above. Even to 7 you must go. This is 6, let us say. And this is 7. This is 0 comma 7. So when you just join them, all the points here, and how does it go actually? It's coming like this, passing through this, passing through this, passing through this, and it's coming like this. So what you should understand, all these points are collinear, and that's the reason, of course, this equation is called a linear equation. I repeat my point, of course. Why do you call it a linear equation? Choose some ordered page satisfying that condition what you got, the linear equation, and choose your ordered page x comma y and plot them on the graph paper and join them. You have to get a line. Because you are getting a line, that equation is called linear equation. And remember that a line is what you see on the graph paper. That's a geometrical representation, but it's algebraically it's given in the form of a linear equation. That linear equation is giving me a line. Therefore, it's a linear equation, we call it. Fine. We take now, say 2 lines we are taking. Okay, in the plane you are taking 2 lines. How they can be like, let us understand. There are 3 different cases when you have 2 lines in a plane. See, this is one line. I want to draw another line, but somehow my second line is coinciding with this one. It is very much on the same. So though I have 2 different names, L and M, both the lines are coinciding with each other. Coincident lines. I repeat here what I mean by this one. I drew one line. My second line, when I wanted to draw, the same points are there on the second line, like whatever I have on the first line, all the points are there on the second line also. So both the lines, they're coinciding. Means every point on the first line is a point on the second line also, and vice versa. And therefore what happened, such 2 lines, in that case we call them coincident lines. Only the names are different. The lines are not distinct. They are not separate. You can't see 2 lines. You see only one. But for some time you are saying it is line L, sometimes you are saying it's line M. So L and M are coincident. But in some other case, like I can have my L here and I can have my M here. But what happened here is the 2 lines, they are parallel to each other. There is no point in common. Line M and line M, L and M, they are distinct, no doubt about it. They are 2 different lines. But unfortunately, there is no point in common. So here the lines can be parallel. Coincident, parallel. And the third case is that I have line L like this and I have line M like this. Line L, line M. And here they're intersecting lines. They meet at a point. So there are 3 different cases, intersecting lines we call them. So when you have 2 lines drawn in a plane, usually we refer to that plane as Cartesian plane. The lines can be coincident, the lines can be parallel, the lines can be intersecting. But how do we recognize them when we are given equations? That's what we have to discuss now. Okay, when we are given a pair of linear equations, or you can say system of linear equations. System is having more than one lines actually. Okay, represented by the equations, linear equations. So that's what we are going to study now. We take a system of linear equations and 2 equations we are going to take, and we want to study, of course, what is the nature of those 2 lines. Are they coincident? Are they parallel? Are they intersecting? How do we determine if the system is consistent or inconsistent? There are 2 different ways of looking at the things. Number 1, what's the nature of the lines we are getting? Number 2, is the system consistent or inconsistent? That's our study is all about. I have 2 equations here. So a1x plus b1y plus c1 is equal to 0. This is the first equation. And the second one is a2x plus b2y plus c2 is equal to 0. Okay, now let us understand how exactly this is going to work. When you take the ratio of the coefficients of x, we get a1 on a2. When you get ratio of coefficients of y, b1 and b2, b1 on b2 of course, and you have c1 on c2. Okay, and now if the first two are not same, okay, if a1 and a1 by a2 is not equal to b1 by b2 and the system is consistent, you're not going to change it like a different version or whatever. Like if a1 on a2 is not same as b1 on b2, if these two are different, don't bother about this one. The system is consistent and you are going to get intersecting lines. And when the lines are intersecting lines, when you are getting, there is only one point of intersection. One point of intersection. One point of intersection. I repeat, when you are given two equations, determine the ratio of x coefficients and determine the ratio of y coefficients. If you have a different answer there, the system is consistent, you are not changing anything. I tell you what we mean by changing or not changing. These two are different, and then you are going to get two intersecting lines and the system is consistent and there is only one point of intersection. Let us take now, if these two are same, means if a1 on a2 is the same as b1 on b2, there are two cases that are going to arise. It may be equal to c1 on c2 or it not equal to c1 on c2. So the first two are equal, a1 on a2 is equal to b1 on b2, but it may be equal to the third one or it may not be equal to the third one. Let us understand what we mean by this. Say for example, I write here an equation like this. Okay, x plus y equals 7. The same equation I am going to write, okay, by multiplying throughout by 2. Means this is a 2x, this is a 2y, and this is, let's say, 14. Look at the ratio of like x coefficients, y coefficients and constant. This is 1 on 2. This is also 1 on 2. And 7 on 14 is again 1 on 2. Means these two are not two different lines. You are consistent. You have not changed anything because whatever you are saying, agreed with that actually. These two, they are in agreement. Okay, absolutely no problem. But the ratio is 1 on 2, is the same as this 1 on 2, is the same as this 7 on 14. And these two lines, they are not different. They are one and the same. And therefore, what kind of system are you going to get? There is one line, another line is the same. Coincident lines you are going to get. So if a1 by a2 is equal to b1 by b2 is also equal to c1 by c2, the lines you are getting are coincident lines. System is consistent. You are not making any changes. You are agreeing with the first line in the second line also. So it's consistent, coincident lines and infinite solutions, because every point on line 1 is on line 2 also. If you want to tell me some points which are in common, every point is in common. Okay, that is number one. And second thing is, I show you one set of linear equations. Suppose I say this is x plus y is equal to 7. Okay, and the second one is, say, twice x plus twice y is equal to, actually I should get 14. I give something else. If you simplify this one, if you want to look at it, it may look like this also. X plus y is equal to 5. Because these two are same. Remember that. Because you divide throughout by 2, you get this one. If you look at this equation and this equation, you are not consistent. You said, tell me two numbers whose sum is 7. And again you are asking me, so the same two numbers if you add, you must get 5 also. How can I get that? Sum of two numbers I must get 7, and the same sum of the same two numbers I must get 5. It's ridiculous, in fact. It doesn't happen. And therefore, this line and this line, if you look at them on the graph paper, there is no point in common. You can never get a point which satisfies both the conditions. It does mean emphatically that the lines must be parallel. So there is something here you should understand. Here whatever you said, here you are contradicting, and therefore the system is inconsistent. You are not telling the same. You told something there and something else you are telling here, and therefore that inconsistency leads to a set of parallel lines, and there is no solution there, because parallel lines, they do not have any point in common. So now I will generalize and write here. If all the three are same, A1 by A2 is equal to B1 by B2 is also equal to C1 by C2, what happens? They're consistent, no problem. You are not making contradictory statements, but there are no two different lines. It's only one line. So when there is only one line, they are coincident lines. And there are infinite solutions for that, because all the points are common. You can call them infinite solutions. But look at this case. Look at this case. What happened here is A1 on A2 is equal to B1 on B2, but it's not equal to C1 by C2. Just now I said there is inconsistency here. There is inconsistency, and that's what I have to make a note of, inconsistent. Then what kind of lines do you get? You get parallel lines. And you don't have a solution there, of course. Therefore, parallel lines, there is no point in common. So, no solution. Okay. And try to understand three different cases. First, you check if A1 on A2 is not equal to B1 on B2. And this result will give you, it's a consistent, you're not making any different statements which are contradictory, you're not denying what you mentioned. And here you get intersecting lines, and when the lines are intersecting, there is one point of intersection and there is one solution. This is the first case. Okay, I just take, this is case number 1, case number 2, and case number 3. This is the first case, intersecting lines. Okay, first case. How do you get the first case? If A1 on A2 is not equal to B1 on B2, you can have this conclusion. But by any chance, if the first two are equal, the two ratios are the same, like A1 on A2 is equal to B1 on B2, now there is a question, you have to wait for some time. So these two are equal. A1 on A2 is same as B1 on B2 in both the cases, here and here. Then you should look at the third ratio. Is it also equal to C1 on C2, or it is not equal to C1 on C2? Okay, these two are different cases. If it is also equal to C1, C2, you are making two statements. The two statements are not different, it is only one. Means the lines are coincident, there is only one line, you are calling it by two different names, two different equations you have given. Consistent, because there is no change in what you said. But remember, as the lines are not two different lines, it is only one line, you get infinite solutions. Case 2 is, this is my first line and the same is my second line. Okay, and coincident lines there. And this is this case. Consistent, but the thing is, they are coincident lines. When you have coincident lines, when one line is falling on the other line, every point is a solution. There are infinite solutions you get. And the last one, first two are equal, but it's not equal to the third one. So what is this case actually? This is a contradiction. You said earlier something, x plus y is equal to 7, and again you said x plus y is equal to 5. You tell me a point which satisfies both the conditions. Okay, that there is a preposterous, in fact, there is no such point, of course, where the sum is 7 and where the sum can be 5 also. It can't be 7 and 5 simultaneously, and therefore we rule out such possibilities. and such lines we get them parallel lines. If you have a point on line 1, it can be on line 2. If it is on line 2, it can be on line 1. So parallel lines. And because these parallel lines you got because of the inconsistency. Okay, it's inconsistency. It is there on line 1, it can be on line 2. If it is on line 2, it can be on line 1. That is what we mean by inconsistency, of course. And finally, there is no solution because parallel lines, they don't meet. Okay, parallel lines, the distance between the perpendicular distance is same throughout. Okay, and therefore there is no point in common. However long you extend those parallel lines, they never intersect actually. Okay, fine. And before I go a little further, I just want to tell you about parallel lines. And when you are asked, of course, what are parallel lines, don't quickly say that the lines which do not intersect. Okay, and I just want to tell you, there is one line here and this is another line. And these two lines are like this, they don't intersect, but I don't call them parallel. So necessarily there is a condition, of course, before you start talking about those lines, they should be in the same plane first. They should be in the same plane. Okay, so there should be a plane which supports those two lines. And then you tell me if they don't intersect, they are parallel lines. And therefore, when you talk about the parallel lines, it is essential for you to start with two coplanar lines. That's how you have to begin. So they should be in the same plane, and now when they don't intersect, they are parallel. Okay, and these are parallel lines and intersecting lines. They are meeting at one point, and they are coincident lines because of one line over another line, of course. All the points are in common, they are coincident lines. So we are talking about two lines essentially in the same plane, which you call it generally as a Cartesian plane. And now tell me there are three different cases. First case we said intersecting. Second case, if A1 on A2 is equal to B1 on B2, it's also equal to C1 on C2. You're not giving me two different lines. You're giving me the same line. And coincident system. Consistent. But there is no second line there. It's only one line. The second line you are talking about is same as the first line. And the third case that you're inconsistent. You said something here, you're telling something different here. You're making contradictory statements. In such a case, what happens? I can't get a solution. If the point is here, it can be here because the lines are parallel. And that's the third case we have got here. So if A1 on A2 is equal to B1 on B2, but it differs from what C1 on C2 is. And therefore here you get parallel lines and no solution. But of course the system is inconsistent. There's something fundamentally wrong. You differed in making statements. Okay, fine. I show you three examples once again, and so that we understand how we get the lines like. My example goes like this. If I have 2x plus y is equal to say some 12 and x minus 2y or x plus 3y is equal to, okay, and this is, let us say, 11. You look at this system. Let us decide what kind of system we are going to get. First, A1 on A2. A1 on A2 is equal to 2 on 1. Hence 2. Now, B1 on B2, 1 on 3. Leave it as, of course, 1 on 3. You look at this one and this one. They differed. That is a conclusive proof to say that these lines are intersecting lines. Here what happened? I need not go for C1, A1 by A2 is equal to B1 by B2. And this is a 2, this is 1 on 3. Okay, they're different. I mean, they are not equal because this is 2. What we got here? This is 1/3. And if the first two are not same, problem is done. What kind of thing? You are consistent, you haven't consistent, and because this can be true and this also can be true, no problem. They're consistent, and you are going to get intersecting lines. When you have intersecting lines, you get only one solution. There is only one point in common, one solution. And if you want to understand, of course, what kind of solution you can expect, you have to solve this system. You have to solve this system. Let me take the system 2x and y, 12, and x plus 3y is equal to 11. I try to solve this system. Okay. Now, either I have to equate the x coefficient or I can equate the y coefficients. How can I equate? This is 3y and this is y. Or I can multiply throughout by 2 here. This becomes 2x and there is a 2x here already. So what I do now is, second equation I multiply throughout by 2. This equation throughout by 2. Come on, 2x. 2 times 3y, 6y. 2 times 11, 22. Second equation is multiplied throughout by 2. And copy down the first equation without making any alterations. Like first equation, I just want to copy down. Come on, first equation. 2x plus y is equal to 12. When I have two equations like this where x coefficients are same, I can subtract. So that goes off actually. So 2x minus 2x goes off, cancelled. Come on, 6y, take away 1y, you get 5y. And 22, take away 12 from this, minus 12 is 10. And it implies 5 times 2 is 10, y value 2 I got. And y value I can substitute here in the first equation. So twice x plus y is equal to 12. Twice x is equal to 12 minus 2, 10. And x value is 5. So I got a clear 1 point. X value is 5 and y value is 2. So you should understand something here. When you try to solve the system of the equations, you got a specific x and a specific y. There's only 1 point and that is common for both the lines. So how do you understand that 5 comma 2 is a point here? 2 times 5, 10 plus 2 is equal to 12. So 5 comma 2 is a point on the line. 5 plus 3 times 2, 5 plus 6 is 11. So 5 comma 2 satisfies this line and this line also. 5 comma 2 is a point on line number 1 and line number 2. And therefore there is only one solution. There can't be any other solution. The lines are intersecting. They can't intersect in any other point. Okay. And remember this point actually, if two lines are there intersecting in one point, they can never intersect in any other point. There is no chance, of course, they meet once again. Okay, I just want to throw a little light on that. Let us say there are two lines. These two lines are intersecting here, say at P. So my contention is that they never intersect once again. How do you know that actually? Because like if you extend this one, maybe do they meet somewhere? Let us try that. You see, if it is possible, of course, you make a supposition. We don't know, somewhere after a few kilometers, let us say, if you say they meet here at Q also. It's a supposition made, it's an assumption actually. But what happens then? There are two distinct points, P and Q. And when there are 2 points, you can draw only one line passing through them. But here you drew 2 lines. So you have P and you have Q here, and you drew 2 lines. It is against the Euclid's axioms, and therefore they don't meet. If at all they meet, it is against the axiom which we learnt actually, Euclidean axiom. And therefore your supposition is wrong. When your supposition is wrong, what is right? They don't meet once again. They have met once, enough. So 2 lines, if they are intersecting at one point, they never do so again. And you got one point here and you can't think of any other point, of course, where they can meet once again. That doesn't happen. So now this is one case we have seen where we have seen a system which has given us intersecting lines. I take one more case. I have an equation given here, say 3x plus 2y is equal to say some 15 or something. Okay, I am given one line. Now I want to write another line. But how did I start? I said doubled this one, I doubled this one, and I doubled this one also. It's not a contradiction. Remember that. I am not saying something against the first one. But second one is not different from the first one. So I have to be given 2 lines, but I have only one line. Only thing is you are multiplying the equation throughout by 2. So when I draw a line for this equation and I try to draw a line for this equation, both these equations give me the same line. And therefore, where is the question of solution actually? Because with one line, I can't have a solution. If you give me 2 lines, I can tell and which point is in common there. Like. And here, what happened here is, come on, look at the ratio. A1 by A2 is 3 on 6. This is 1/2. Come on, B1 on B2. It is 2 on 4. Is again 1 on 2. And now I have to check what happens to C1 on C2. Because these two are already equal. But when I try to check, even that is same. C1 on C2 is again 1 on 2. Because it's 15 on 30. 15 ones and 15 twos. Is again 1 on 2. So what happened here, what happened here, what happened here, all the 3 are same. And therefore, these 2 lines, they're consistent. There is nothing one against the other. But the thing is, these 2 are in agreement. Okay, I'm not saying something against this when I say this one, but these 2 are not different. Okay, so we write here, the system is consistent. And these 2 are not different means this line and this line are same. So you get coincident lines. When you have only one line, how many solutions you have? Infinite solutions you have. Infinite solutions. Let us understand, this is my first line and I try to draw the second line and the second line is coming exactly on this. Okay, second equation for. So there are 2 different names, that's it. The lines are coincident. I got infinite solutions. If there's a point on line 1, it is on line 2 also. And therefore, it will give me infinite solutions. This is the second case where we have got infinite solutions. I discuss the case of parallel lines once again. You can say this is my first line. Okay, second line I want to draw and I said, okay, I doubled this one. I doubled this one, 2x and 2y, but I am not doubling this one. I am writing something different. I just say twice this is 10, but I am writing say some 11. So what you said here, you are contradicting. You are telling something different. Double this and double this, must double this 5 also, 10 you should get. You are telling 11. This is what you mean by inconsistency. There's something different. You said something and the second one is not in agreement with that. So we say this is an inconsistent system. And there can never be points which satisfy this and this. You're getting parallel lines. And is there any solution that you can look for? No, there is no solution. Parallel lines, they never meet. And there is no solution. So this is how you have to understand. I give you one example. I try to draw the graph. X plus y is 7 and I want x plus y is equal to say 5 also. Sum of 2 numbers must be 7 and the same 2 numbers if you add you must get 5. But it's a ridiculous one. It doesn't happen. Let us try to draw the graph. X-axis and y-axis. And I mark here 1, 2, 3, 4, 5. I just extend it a bit. 6 and 7. And I go towards this positive y-axis 3, 4, 5, 6 and 7. I try to draw the graph of the first one. It can be 7 plus 0, 7. 0 plus 7 is 7. So there are 2 points. One is 7, 0, another one is 0, 7. One point is on x-axis and one point is on y-axis. It can be, this is 7, 0 is here and 0, 7 is here. And my graph is a simple graph joining these two. That is done. And this one I want to draw. Okay. 2 numbers if I add I should get 5. I just take 5 and 0. That's easy for me. 5 plus 0 is 5. And I take 0 plus 5 is 5. So the 2 points here I am getting on the second one is, it is 5 and 0 and 0 and 5, and this is my second graph. And what I have found essentially is that the lines are parallel and there cannot be a solution. Consistent, I mean inconsistent they are. You said x plus y is 7 and again you are telling x plus y is 5. I can't give you x and y which satisfy both the conditions, where the sum is 7 and where the sum can be 5 also. Like it is ridiculous in fact. Like if it is 7 it can be 5, if it is 5 it can be 7, and therefore the system remains inconsistent. The lines are parallel and you can't expect a solution for that because there is no common point. Okay, there is no common point lying on both the lines. So this is what we mean by inconsistent, lines are parallel and there is no solution. Okay, and if with that introduction, if you are given two equations, we have a number of methods of solving them. You can solve by substitution, you can solve by equating the coefficients, you can use a cross multiplication formula, and there are a number of ways. And our exercises intend to cover the different ways we use to solve the system of linear equations. That's it. A few systems we will consider and we try to solve them, and assuming that of course in most of the cases you have one solution where the lines are intersecting. Okay, fine, let us start our work. I take say exercise 3.2 and you are given a pair of linear equations. What you need to do is, don't need to solve, but you should comment on the kind of solution you're going to get. Okay, on comparing the ratios when the lines represent the linear equations intersect at a point, are parallel or coincident. You have to determine that. This is simple finding the ratio, nothing more than that. And my first sum goes like this. And I have 5x minus 4y and plus 8 equals 0. And the second one is 7x plus 6y and minus 9 is equal to 0. And I just want to find out first a1 by a2 and b1 by b2. And a1 by a2 is equal to 5 on 7. And go for b1 by b2. It is minus 4 on 6, which can be simplified to write minus 2 on 3 because I cancelled a 2 in both. You look at this one and look at this one. They are different. And that is conclusive. You don't need to do anything more than that. If these two are different, immediately you say intersecting lines. That's it. And intersecting lines means you are going to get one solution. Okay, the system is consistent. Okay, and I take a case here. My second problem is slightly different. 9x plus 3y plus 12 equals 0, and the next one 18x plus 6y plus 24 equals 0. I am going to find out a1 on a2, 9 on 18, it is 1 on 2. Next one, b1 by b2, it is 3 on 6, again 1 on 2, 3 ones are 3 twos are. Next one, c1 on c2, 12 on 24, 12 ones are 12 twos are. All the three are same, means a1 on a2 is the same as b1 on b2, is also same as c1 on c2. You are consistent, no problem, you are consistent, but the lines are not different. They are one and both the lines are same. So coincident lines you will get. Coincident lines. Can you look for solutions? Yes, infinite solutions. Infinite solution, because the lines are same. There is only one line given, not two different lines. Infinite solutions you can expect, because the lines are coinciding with each other, you can expect. And question number 3, on comparing the ratios, find out whether the following pairs of linear equations are consistent or inconsistent. When do you say consistent? Okay, if a1 on a2 is not equal to B1 on B2, it's okay. Intersecting lines, okay. In intersecting lines and coincident lines, that is consistent system. Only when the lines are parallel, you say inconsistent. That's it. So, I just write here, A1 on A2 is not equal to B1 on B2. You are consistent. A1 on A2 is equal to B1 on B2, but is also equal to C1 on C2. Now you are consistent. There is no problem. Either the lines are parallel, coincident lines or intersecting lines. Inconsistent comes in only one case. A1 on A2, inconsistent comes when you have parallel lines. Is equal to B1 on B2, but remember, is not equal to C1 on C2. Then I say, only in this case, inconsistent. Inconsistent means parallel lines. So, intersecting lines, coincident lines, consistent system. Only when you have parallel lines, inconsistent system. That's it. If you can remember this much, parallel lines. Okay. So, I take few more sets here. Okay, you are given the linear equations and he is asking you to solve the systems graphically. So, you need to take a few points which satisfy the conditions, first equation, second equation, plot the graphs and try to find out the nature of the equations. That's what we are going to do now. We are trying to work out, to find the solutions of pair of linear equations given to us. And we have different methods and let us watch them. Solving a system of linear equations, that is our interest actually. Solving a system of linear equations. The first method we have is graphical method and the second method is substitution method and third method is elimination method and the fourth method is cross multiplication. So we employ one of these methods to solve the pair of linear equations given to us. And now I do now the substitution method. Find the value of one variable in terms of the other variable, x in terms of y or y in terms of x. And by substitution, we eliminate one of the variables. Okay, this substitution method, we just say eliminate y because y is written in terms of x. That's what we mean by this substitution method. Let us try to do a problem to understand this one. Suppose you have x plus y is 14 and x minus y is 4. So this is an easy guess to solve, okay, because sum of the numbers is 14 and the difference is 4. Okay, and you can guess 9 plus 5 is 14 and 9 minus 5 is 4. But however, what is that method we are following here is, this is first equation and this is second equation. And from the first equation, tell me what y is all about. So y is equal to, from the first equation, 14 minus x. Okay, we got it from first equation. From the first equation, we got the value of y. And this value of y we substitute in the second equation. So now y value in equation 2. Wherever you have y, you substitute this 14 minus x. X minus, in place of this y, I am writing this 14 minus x. And that is 4. So x minus 14 minus of minus x plus x is equal to 4. Twice x is equal to, minus 14 will go to that side, plus 14 and 4 gives you 18. It implies x is equal to 18 on 2 and that will give you 9. Now, once you know that x is equal to 9, y is equal to 14 minus 9. 14 minus 9 will give you 5. So this is how you got x is equal to 9 and y is equal to 5. And this system where y value is found in terms of x and that is substituted in the second equation, and this method is called method of substitution. Let us take up a few more problems and start working. I have an interesting problem here, and it is a fourth bit actually. Like this is exercise 3.3. It's a fourth bit. And my second question here, 0.2x plus 0.3y is equal to 1.3. And the second one, 0.4x plus 0.5y is equal to 2.3. For my convenience sake, what I do now is I multiply throughout by 10. I tell you the advantage I get, because there won't be any decimal left there. Because after the decimal you have only one place. When that number is multiplied by 10 and that decimal goes off. So the first equation is multiplied throughout by 10. Okay, fine, you can write 2x and this becomes 3y and this becomes 13. Now I say this is my first equation. And second one I multiply throughout by 10, this becomes 4 and this becomes 5y. And this becomes 23, and this is my second equation. How are we going to solve? Find the value of y in terms of x. I take my first equation, 3y is equal to 13 minus 2x, 13 minus 2x, and hence y is equal to 13 minus 2x, this 3 will come down by 3. This I got from equation number 1. And if this is substituted here in the second equation, I am going to get 4x plus 5 times y, 5 times, what is y? 13 minus 2x by 3 is equal to 23. My LCM of denominators is 3. 3 times 4x is 12x. In this 3 goes one time, whatever I have on the top, 5 into 13, 65, 5 into minus 2x is minus 10x is equal to 23. Further, 12x minus 10x is 2x plus 65 is equal to 3 times this 23, 69, and twice x is 4. 69 minus 65 is 4. It implies x is equal to 2. Once you got x is equal to 2, you can substitute here. 13 minus 2 times 2, 4. 13 minus 4 is 9. 9 on 3 is 3. So if x is equal to 2, y is equal to 3. Okay. So this method is substitution method. We'll take up another problem. 2x plus 3y is equal to 11. This is my second problem in the exercise. Okay. 2x plus 3y is equal to 11 and 2x minus 4y is equal to minus 24. Hence find the value of m for which y is equal to mx plus 3. So when you solve these two equations, you get some values for x and y, and just plug in that y is equal to mx plus 3 and you can find out m. Okay, let us start. This is my second question in the textbook, my third one here, like 2x plus 3y is equal to 11, and the next one 2x minus 4y is equal to minus 24. Okay, and whenever you are given an equation which has got, say, a common factor throughout, you try to cancel. Why do you want to entertain that one? It is only, like a burdensome to have larger numbers. So I said it is because of this 2x. 2 goes in this one, 2 goes in this one. But at this moment, it may be advantageous for me because I can subtract from this one, because both are equal. I'll do that. That would be better. So I have 2x plus 3y is equal to 11. I copied my first one. Second one I am not changing for a very reason. So I write 2x minus 4y is equal to minus 24. The second equation is written as it is. Come on, upon subtraction, 2x minus 2x gets cancelled. 3y minus of minus 4y, 3y plus 4y, that is 7y, is equal to 11 minus minus 24. 11 plus 24, that will be 35. And it implies y value is 5. 7 5 is 35. Now, if you substitute this y value in any of these equations, you can get x value. So, let me put in first equation, of course. Twice x plus 3 times y is 11. So, twice x is equal to 11. This 15 will go to that side, minus 15. So, twice x is minus 4, and hence x is equal to minus 2. And he is asking, an additional question there. He says, my y is equal to mx plus 3, and tell me what m is. Okay, so you are given another line which passes through the point of intersection of the first two. There are two lines here. And through that point of intersection, the third line is passing. That's why you are substituting. Come on, x value minus 2 plus 3. And what is this y value actually? You got 5. You have to find out m value. That's it. Come on, 5. Bring 3 this side. Minus 3 equals minus 2m. And m is equal to, this is 2 and this is by minus 2. 2 on minus 2 minus 1. And therefore, m value is minus 1. Okay, so he said, having got the values for the first pair of linear equations, if that is substituted in another line, y is equal to mx plus 3, and going to get the value of m there. Okay, and from the form the pair of linear equations for the following problems and find their solution by substitution method. Okay, he just mentioned. Okay, third question, and I will do my first bit. He says the difference between two numbers is 26 and one number is 3 times the other. Find them. Okay, and let the numbers be x and y. Let the numbers be x and y. He says the difference between them is 26. So x, let us say this is the larger number, minus y is equal to 26. Okay, there is a possibility of taking y larger, in which case you write y minus x is 26. Perhaps, let's see if that can give you a different result. The second one says one number is 3 times the other. You said this is the larger number and this is the smaller number, and one number is twice. He has given the difference is 26. Difference x minus y. Next one number is 3 times the other. One number is 3 times the other number, in which case x becomes 3 times y. That's it. The difference between two numbers is 26, and one number is, larger number is 3 times the smaller number. And this can be easily substituted because in place of x I can write 3y. I do it here come on. This is first equation. This is second equation. This x value in terms of y will be written in the first equation. Here is x. So write 3y minus y is equal to 26. Twice y is 26. Y is equal to 13. So y value I got. Now I can get x value, of course, is 3 times y. Is 3 times 13, and that is 39. So the numbers are 13 and 39. How do we understand that? The difference is 26, 39 minus 13. And the second thing is 39 is 3 times this 13. Larger number is 3 times the smaller number. I take say the third bit of third question here. The coach of a cricket team buys 7 bats and 6 balls for 3,800. I straight away write like this. How many bats? 7 bats. Let the cost of the bat, let the price, you should say, let the price of bat be X and the price of the ball be Y. So you have the price of bat and ball. And now let us substitute 7 bats and 6 balls. 7 bats, 6 balls. The coach has purchased and he paid 3,800 for that rupees. And the next one, later he buys 3 bats and 5 balls. 3 bats and 5 balls. And how much did he spend for that? 1750. So there are 2 equations which we should solve them. Find the cost of each bat and each ball. 1 bat, 1 ball. How much do they cost separately? So substitution when you're doing, of course, I just find say 6y is equal to 3800 minus 7x. Let us start. 6y is equal to 3800 minus 7x. And hence y is equal to 3800 minus 7x. This 6 will come down by 6. So I have found the value of y in terms of x. And this should be substituted in the next equation. Where is the second equation? Second equation is here. This is first equation, this is second equation. From first equation I got value of y. And this must be put in second equation. So let us start. 3x plus 5y. 3x plus 5y is equal to 1750. And 3x plus 5 times. I write the y value. 3800 minus 7x. 3800 minus 7x by 6 is equal to 1750. 6 is the LCM of denominators. 6 times this 3x will be 18x. In this 6 goes only one time. 1 into whatever you have on the top. Come on, tell me what do you have on the top? 5 times this one. 15,000 and 5 times 800, 4,000 of course. 5 times 0, 0. 5 8s 40, 0 4. 5 3s 15 and 4 19. Minus 5 times 7x, 35x is equal to 1750. Now 18x you have got, but you have to take away 35x. It is minus 17x. 18 minus 35 is minus 17x. Of course you got 19,000 here is equal to 6 times this one. You tell me that 6 times 0, 0. 6 times 5 is 30, 0, 3. 6 times 7, 42 and 3, 45, 5, 4. 6 times 1, 6 and that 4, 10. And now this also goes to that side. Minus 17x is equal to 10,500 minus 19,000. And difference is 8,500. But this is larger, negative. Minus 17x. Minus can go, x value is 8,500 on 17. 17 5s are 85, 0, 0. I got x value. And this x value is substituted here to get the value of y. And my y is 3,800 minus 7 times x is 500 divided by 6. So 3,800 minus 3,500 is 300. 300 divided by 6. That's it. And that gives me 50. So bat costs we found where x value is 500 and y is the cost of ball and it is 50. Okay. So that's how we form an equation and we solve it. I have fifth bit now. Here a fraction becomes 9 on 11 if 2 is added to both the numerator and the denominator. Okay. If 3 is added to both the numerator and denominator, if 3 is added, it becomes 5 on 6. Find the fraction. Now I start like this. Okay. Let the fraction be x on y. Let the fraction be x on y. And he says if If 2 is added to both numerator and denominator, the fraction becomes 9 on 11. So you are adding 2 to the numerator and the denominator, and the fraction becomes 9 on 11. Okay, this is what happens, of course, when you add to both numerator and denominator. Cross multiplication, 11x plus 22 is equal to 9y plus 18. So 11x minus 9y is equal to 18 minus 22 minus 4. That's my first equation. There is another clue given to you. Okay, and he's taking the fraction, he's adding 3 to both numerator and denominator, and the fraction becomes 5 on 6. So you have x plus 3 and y plus 3, and that becomes 5 on 6. Cross multiplication, 6x plus 18 equals 5y plus 15, and 6x bring 5y is equal to minus 3. This is the second equation. And now he is asking you to solve using substitution method. Okay, so can we have y from this? What we do here is we find the value of y from the first equation and substitute that in the second one, as simple as that. So I take my first equation once again, 11x minus 9y is equal to minus 4, and minus 9y is equal to minus 4. This 11x will go that side, minus 11x. Change the sign throughout for convenience. 9y is equal to 4 plus 11x, and hence y is equal to 4 plus 11x by this 9. Now, having got y value from the first equation, this y value will go into the second one. Okay, that's what we need to do. Like here, 6x minus 5 times. In place of y, I substitute this one, 4 plus 11x by 9. 6x minus 5y equals minus 3. Now 9 is the LCM of denominators. 9 times this 6x is 54x. In this 9 goes only one time, whatever you have there. Come on, write down. Minus 5 times 4, minus 20. Minus 5 times 11, minus 55x. And that is minus 3. 54x minus 55x is minus x. Of course, minus 20 here is equal to 9 times minus 3, minus 27. And minus x is minus 27 plus 20. That is minus 7. Obviously, x is equal to 7. Now, x value we plug in here. In this, we get the value of y. Come on, y is equal to 4 plus 11 times x value 7 over 9. 7 times 11 is 77. 77 and 4, 81. 81 by 9, and that is 9. So hence your solution is this one, like x value is 7 and y value is 9. So this is about a fraction and the kind of manipulations he is doing, adding to the numerator, like adding some other number or subtracting, whatever it is. So in all such cases, of course, the problem is in terms of the fractions you've given, you can assume the fraction to be x on y and start working out. Okay. And now we go to elimination method. And when you are eliminating, the point here that you should remember is equate the x coefficients or y coefficients. Okay. If they are equal, subtract. If they are equal numerically but with a different sign, one is positive 7, one is minus negative 7, then you can add them, they get cancelled. So either by adding or subtracting, we can cancel. That's what we mean by elimination. So let us understand what we exactly mean by that and see the problems here. Multiplying throughout by some number, you can equate. Okay, this is exercise 3.4 and the method we are following is elimination method, and he is also asking you to verify, in both the method, second next substitution method also. Anyway, fine, let us start working out. 3.4. I first focus on my elimination method. X plus y is equal to 5 and 2x minus 3y equals 4. Two equations you are given. And you can't do either addition or subtraction, whatever it is, in this condition because the coefficients are different. This is 1, this is minus 3, this is 1, this is 2. And equate the coefficients of either x or y. There is no problem. So, if this is minus 3y, I can get here 3y. Okay. So, what should I do then? If I want 3 here, I should multiply throughout by 3. So, first equation is multiplied throughout by 3. And that's going to give me 3x plus 3y. 3 5 is 15. Okay. So, what is the advantage of this is I have 1y. When I multiplied throughout by 3, I got plus 3y. And now I have these two equations. This is plus 3y, this is minus 3y. When you add them, they get cancelled. Okay. So, that's what I should do now. And 3x and 2x will give me 5x. Plus 3y and minus 3y, they get cancelled. And 15 and 4, if you add up, it's 19. So, my x is already there. 19 on 5. Okay, I can say this is divide this one, or better I can leave it like this. So anyway, fine. 5 3s are 15. 4 and 5 will be 0.8, 3.8. Fine. This is better for the manipulation. Fine. This x value will substitute in the first equation. Come on. X value is a 19 on 5. Plus you have a y there, 5. And y value is 5 minus 19 on 5. This will go to that side. And 5 times 5 is 25. 25 minus 9 is 6 upon this 5. And here it is clear now. X is equal to 19 by 5. And y is equal to 6 by 5. That's it. Okay. And there are some word problems here. Let us try. From the pair of linear equations in the following problems and find their solutions, if at all they exist, by the elimination method. If we add 1 to the numerator and subtract 1 from the denominator, a fraction is reduced to 1. Okay. If we add 1 to the denominator, if we only add 1 to the denominator, it becomes 1/2, 1 and 2. And what is the fraction? And we did one problem earlier. Forming the equations you can do first, and later the question of method comes, whether you are using elimination or substitution. In this particular exercise, you are supposed to use the method of elimination. That's it. The same problem you may have in the previous exercise and this exercise. What does make a difference is the method you are employing. Okay, fine. Now, let the fraction be x by y. Let the fraction be x on y. And here he says, if we add 1 to the numerator, x becomes x plus 1. And subtract 1 from the denominator, from y take away 1. And if the fraction reduces to 1, it is just 1. Okay, so cross multiplication, x plus 1 is equal to y minus 1. And x minus y is equal to, this plus 1 comes to this side, minus 2. That's the first equation. And the second hint he is giving, okay, and if it becomes half if we only add 1 to the denominator. So numerator he is not disturbing, and he is adding only 1 to the denominator, y plus 1, and the fraction becomes half. So cross multiplication, 2x is equal to y plus 1, and 2x minus y is equal to 1, and this is your second equation. And you bring down this one, like first equation you write here, x minus y is equal to minus 2 is the first equation. I observe something interesting here. It is minus y and minus y, both are same, but how do they go? Only when you subtract, because from minus y, if you take away minus y, there is nothing left there. So I am subtracting now, because this x becomes minus x, 2x minus x will be x. This minus y becomes plus y. Minus y and plus y gets cancelled. This minus 2 becomes plus 2 and 1 plus 2 is 3. I got x value. This x value can go here or anywhere. Okay, here you got an equation, of course, first equation or second equation. Substitute this x value. X value we are substituting in equation 2. X value in equation 2 you are trying to substitute. Come on, 2 times x minus y is equal to 1. This is 6 minus y is equal to 1. Obviously y is equal to 5. And therefore the fraction is x value is 3, y value is 5. The fraction is 3 on 5. So let us understand what, like how we can verify this one. He says add 1 to the numerator. This becomes 4. Subtract 1 from the denominator. This becomes 4. And 4 on 4 becomes 1. Add 1 to the numerator and subtract 1 from the denominator. 4 on 4 it's 1. He says if only you add 1 to the denominator, okay, 3 on 6 it becomes, that is half. Okay, that's how you can verify it actually. And I'm doing the fifth bit here. A lending library has a fixed charge for the first 3 days. First 3 days the same amount is taken and an additional charge for each day thereafter. Okay, a number of days, if you are using the book for more time, you have to pay for each day, you have to pay some y rupees. Initially for the first 3 days, you got the same pricing, of course, it's only rupees x you have to pay. And now Sarita paid 27 rupees for a book kept for 7 days. Kept for 7 days. Okay, 7 days if she has kept the book with her, first 3 days she has to pay x. And additional 4 days she has to pay the penalty. Okay, so that's how we start working out. In this problem, it's a lending library problem, and you first 3 days you pay a fixed amount. But if you're going to continue using the book for a longer period, for each day you have to pay some penalty, and let us say that is y. Okay, for this problem, first 3 days is a fixed charge. First 3 days, let us say you need to pay rupees x. This is a fixed charge. And for additional day, let us say y rupees per day. For additional 1 day, let us say rupees y. So this is your supposition. And here there are 2 people, 2 different cases you are given. And Sarita paid 27 rupees, okay, for using the book for 7 days. She kept the book for 7 days. So first rupees x and 4 additional days, and then she paid 27 rupees. How did you get this? Sarita used the book for 4 more days. So for that 4 additional days, because she used the book for 7 days, first 3 days of course it's okay, she is paying x for that, and for additional day y, additional days are only 4 because it's 1 week. And in case of another Susi, she said she used the book for 5 days. She used the book for 5 days. She paid 21 rupees. So for the first 3 days x and additional 2 days. So, and she paid 21. Okay, because Susi used the book for 2 more days. 2 more days. This is what you should remember. 5 days means 2 additional days. 7 days means 4 additional days. I have 2 equations. X plus 4y is 27, first equation. And x plus 2y equals 21. This is second equation. A simple subtraction will help me. X minus x goes off. 4y minus 2y is 2y. And 27 minus 21 is simply 6, and it implies y is equal to 3. So 3 rupees is the charge for the additional one, like additional day. So rupees 3 for additional day. Okay, and let us substitute y value in this equation, maybe the first equation or second equation. Come on, in the first equation, let us substitute. X I should find out 4 times. Y value I got is 3, and that is 27. And X is equal to 27 minus 12, that is 15. So understand like this. First 3 days, 15 rupees. Okay, first 3 days. First 3 days. Fixed charge 15 rupees. And additional day, it is only 3 rupees. Additional day, rupees 3. That's how you understand it. If you want to verify how exactly this we arrived at, let us say 7 days Sarita used. First 3 days she pays 15, and additional 4 days, 4 times 3 is 12. 12 and 15, that's how she paid 27. And regarding this Susi, she used only the book for 5 days. 3 days she is paying a fixed amount 15. For the additional day, 3 rupees. 2 times 3 is 6. 6 and this 15. That's how she paid the 21. For the first 3 days, 5 days she used. First 3 days, 15 rupees. And 3 rupees for additional day. 2 times 3 is 6. 6 and this 15, 21. So this is how we work out this one. Then the next method is perhaps the most interesting method when you're given 2 linear equations. This is the cross multiplication method. Okay, and let us understand what we exactly mean by this. You have got 2 equations and the coefficients are given to you, and you need to do the cross multiplication. Fine. We have 2 equations, and many people, they use this method because this is very convenient. Because once they get used to this one, like a to x, b to y, and constant c2 is equal to 0. So there are 2 equations here. You need to find the values of x and y. Okay, and follow what I am doing. Write the coefficients first. Coefficients I start from here. So I first write b1, b2, c1, c2. You write a1, a2, and again write b1, b2. b1, b2. Okay, write the coefficients of y, then constants, then coefficients of x, and again coefficients of y. You write on the top x, and here y, and here 1. That's it. If you can understand, rest of the things will become very easy. Now you are coming down like this, let us say, and you are going up, and again you are coming down and you are going up. Okay, and you are coming down and you are going up. It's easy to understand. You are coming down here, going up here, and here whenever you are coming down, take it as positive, and when you are moving up, take it as negative. So here b1, c2 is positive, coming down, and going up is negative. So you have here, write x on the top by b1, c2 minus b2, c1. Now you take y. Coming down is positive, going up is negative. Come on, c1, a2 minus c2, a1. And the last one, it is 1 by a1, b2 minus a2, b1. a1, b2 minus a2, b1. So if you can get this equation, if you want x, take this and this one, like, this part will go up. That's it. You can resolve x. Take first one and the last one. Now take these two. Take these two. If you want y, this will go up by this one. So it's easy to find out. We'll take a problem and do it, of course. I just take, say, 2x plus y is equal to 11, and x minus 2y, okay, and minus 2. This is my first equation, this is my second equation. Okay, we have to solve this system. And let me tell you, you write first x, y, and 1. Coefficients you must write b1, b2. First you must write b1, b2. Means 1 minus 2. Then you should write, bring this 11 this side, of course, that makes sense for us. Here is equal to 0, and bring this minus 2 this side, it becomes plus 2 is equal to 0. Now tell me, B1, B2, I have written here. C1, C2, minus 11 plus 2. Next one, A1, A2, 2 and 1. And again you write B1, B2. Okay, 1 minus 2. Now, once again you see 1 minus 2 is here, minus 11, 2 is here, 2 and 1 is here, and again 1 and minus 2 is here. Come on, x by. This product positive and minus this product. Going up is negative. This is 2. This product is plus 22. Because minus 2 into minus 11 plus 22. Change the sign, minus 22. Next step, y by. Come on, y by. Minus 11 into 1, that is positive. As it is, you should write. And for this, you have to change the sign. 2 to the 4, negative 4 is equal to. Come on, 1 by. 2 times minus 2, minus 4. And 1 time 1 is 1. You should subtract it. This is positive and for this is negative. You have to change the sign. This you write as it is, minus 4. And this you have to change the sign. 1 time 1 is 1, write minus 1. And x by 2 minus 22 is minus 20. Y by minus 11 minus 4 is minus 15. And finally you have 1 by minus 5. X value, if you want to keep this on the top there, okay, x is equal to minus 20 times 1, minus 20 by minus 5. Your answer is 4. Come on, y value if you want, minus 15 times 1 by minus 5, minus 15 by minus 5, that's 3. So you can get the values of x and y by cross multiplication method, okay. And there is an exercise here. And we do a few problems from 3.5, and after 3.5 we have 3.6 where we have some word problems, like one word problems, and 3.6 also we have. Fine, 3.5 I am here, and let us apply this cross multiplication and do. Cross multiplication formula you should remember: B1 B2, C1 C2, A1 A2, again B1 B2. That's it. Okay, and unique solution, no solution, infinitely many solutions, and that's what you have to check, of course. For which values of A and B does the following pair of linear equations have an infinite number of solutions? This is like a mixed bag, and let me take, in the first bit I do one problem. 3x minus 5y is equal to 20. 3.5, first problem, first bit. He is asking you what is the nature of the equations, nature of the lines you are getting. 3x minus 5y is equal to 20. And 6x minus 10y is equal to 40. And if it is possible, you solve it. Otherwise, you just leave it and tell about the nature of the lines you got. A1 by A2 is 3 on 6. Same as 1 on 2. B1 by B2. B1 minus 5 on minus 10. It is again 1 on 2. Okay, minus goes off, 5 ones are 5 twos are. Come on, C1 by C2. You can say 20 on 40. It is again 1 on 2. So if all three are same, the lines are not different. He took the first line, multiplied throughout by, throughout by 2. 2 times 3x, 6x, 2 times this is this, 2 times 20 is 40. So he took the first equation, multiplied throughout by 2. So he is not giving a second equation. First equation depends on the second equation, depends on the first equation. It is a dependent system. It is consistent, no problem. But it is going to give you coincident lines, because lines are not different. They are one and the same. And therefore, it's coincident lines you are given. Means the second line is not different from the first line. You multiplied this by 2, you got this one. This is not a second line, this is only the first line. But only thing is you multiplied throughout by 2, you got the second one. So that is about the nature. Coincident lines you are going to get. Then the second one, the first bit is a very interesting one. For which what values of A and B does the following pair of linear equations have an infinite number of solutions? If you want infinite solutions, you should have coincident lines. That's it. Let us start working out the second question. He says 2x plus 3y is 7. And the second one he mentioned is a minus b times x plus a plus b times y, is equal to 3a plus b minus 2. So when do you get infinitely many solutions? It should be coincident lines. Coincident lines mean what? A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Okay, there should be only one line. Second line is only first line multiplied by something. So fine. A1 by A2, 2 by A minus B, B1 by B2, 3 by A plus B should be same as 7 by this one. 7 by 3A plus B minus 2. If you can understand this, we can find the values of A and B. So where do we begin actually? It's simple cross multiplication. I take this and this. I start cross multiplication. 7 times A, 7A. 7 times minus B, minus 7B is equal to 2 times 3A, 6A. Then 2 times this B, 2B. And 2 times minus 2, minus 4. 7A minus 6A. This is only A. Minus 7b minus 2b minus 9b is equal to, I have only minus 4 left there, minus 4. It's my first equation. I go for my second equation. How I am going to get? See, these two I have to take. Come on, 7 times A, 7A. 7 times B, 7B is equal to 3 times 3A, 9A. 3 times plus B, 3B, and 3 times minus 2, minus 6. 7A minus 9A minus 2A, 7B minus 3B plus 4B is equal to, I am left with minus 6. This is equation number 2. So I have equation number 1 and equation number 2. But here is A, here is minus 2A. And I multiply the first equation throughout by 2 because I get 2a here because this is minus 2a. So my next step is first equation multiplied by 2 throughout. Come on, 2a. 2 into this minus 18b and 2 into this minus 8. And my advantage here is that this is positive 2a, negative 2a. They get cancelled when I add. And I add these two. I get minus 14b. Because minus 18 plus 4, minus 14b, and minus 8 minus 4, it is minus 14. And that gives me b is equal to 1. Having got this value b is equal to 1, I can substitute here in equation 1. Come on, a minus 9 times 1, 9 minus 9 times 1 is equal to minus 4, and a is equal to 5. Because minus 9 goes to that side, 9 minus 5, 9 minus 4 is 5. So these are the values of A and B so that you can have what you needed actually. You said these two lines should give infinitely many solutions because you have chosen that the system should be of coincident lines and the ratio is A1 on A2, B1 on B2, C1 on C2, all three must be same. Okay, and that is 3.5. I do my last problem from this exercise. From the pair of linear equations in the following problems and find their solutions if they exist by any algebraic method, because you are given an open hand. You can use any method. My problem is the first one. I take off this. Here he says a part of monthly hostel charges is fixed. Okay, it's fixed. and the remaining depends on the number of days one has taken food in the mess. Hostel charges remain the same. These are fixed charges. Probably it's for your stay. And additional amount you have to pay depending on how many days you have used the mess. Okay, if you are using for Y days, Y into that something you have to pay. Now he is asking, when a student A takes food for 20 days, he has to pay 1000 rupees. So this is my question. So hostel plus 20 days mess charges, and that student has to pay, she has to pay 1000 rupees, like fixed amount for the hostel, and 20 days mess 1000 rupees she paid. Next one, whereas another student B who takes food for 26 days pays 1180. So hostel plus 26 days she took meals in the mess and she paid 1180. Okay, now you can use any algebraic method, find the fixed charges and the cost of food per day. So it's a very simple problem. Let us say the fixed charges is X and you are using mess for 20 days. 20Y is equal to 1000. And another student B, okay, this is about B and this is student A. What happened to the second student? Hostel charges X and 26 days she used and she paid 1180. This is first equation, this is second equation. From the second equation, I want to subtract first equation. And the advantage I get is X and X, they get cancelled. X minus X goes off. 26 minus 20, that is 6Y, is equal to 1180 minus 1000, it is 180. And Y is equal to 180 by 6, and that gives you 30. And therefore, food charges for a day, food charges per day 30 rupees. Rupees 30. But that's not the end of the story. You have to find X also, like, this 30 we can substitute here in place of Y, and X is equal to X plus 20 times 30, and that's how you got your 1000. And X is equal to 400 because this is 600. 1000 minus 600 is 400. And therefore, fixed charges 400 for staying in the hostel. Fixed charges 400 for each food charges per day 30 rupees. There are two answers here, like this is one answer and this is another one, of course. Food charges per day 30 rupees. Okay, and that is my exercise 3.5. And in this 3.6, a small modification is there. I just do one or two problems. It's not a big deal. And there's a simple problem. So only thing is you must convert them into the linear equations. Now I am in exercise 3.6. In this exercise, the equations given to you, they look slightly different. Okay, they don't look in the conventional way. This is 3.6. I'm doing my first problem. And 1 and 2x and 1 and 3y is equal to 2. And the second equation given is 1 and 3x plus 1 and 2y is equal to 13 on 6. 13 on 6. Okay, so here this is not a difficult question, rather in a different form you are given. So what I do is that wherever I have 1 on x, I replace it by some a, and 1 on y wherever I have, I write b, because that makes my things clear. Instead of having a variable in the denominator, I want to bring it to the numerator, introduce another variable, of course. So put 1 by x is equal to a and 1 by y is equal to b. So my equation turns into, because 1 by x is a by 2, and this 1 by y is replaced by b by 3, and that is 2. LCM is 6. In this 6, this 2 goes 3 times a, 3a. In this 6, this 3 is 2 times it is going, and 2 times b, 2b, and that's 2. And 3a plus 2b is equal to 6 times 2, 12. I got my first equation. Okay. And the same I do it here also in the second equation. 1 by x is replaced by a here, a on 3. And in place of 1 by y, I write b, b on 2. And that is 13 on 6. Let us simplify this one. 3 times 2, 6 is the LCM. In this 6, this 3 goes 2 times a is 2a. In this 6, this 2 goes 3 times b is 3b. And that is 13 on 6. You can close this 6 and 6. You can just strike them off. If I lose my 6 there, denominator, and my numerator is the equation, 2a plus 3b is equal to 13. This is the second equation. And you look at the coefficients there. Strangely, this is 3a, this is 2a. And this is 2b, this is 3b. They are not equal. So what I would rather do is that I multiply throughout by 2 here to make this 6. And I might multiply throughout by 3 here to make this 6. Because with this 2, I multiply throughout. With this 3, I multiply throughout. So first equation is multiplied by 2. Come on, double this one throughout. Multiplied by 2. 6a. 2 times 2b, 4b. 2 times 12, 24. I can say first equation is multiplied by 2. Second equation, I multiplied by 3 throughout. Come on, multiplied by 3 throughout. 6a. 3 times 3b, 9b. 3 times 13, 39. Second equation is multiplied by 3. Come on. It is only simple subtraction. Okay? Because 6a and 6a, they go off. 6a minus 6a goes off. From this, I am subtracting this one. 9b minus 4b, 5b is equal to 39 minus 24, 15. It implies b is equal to 3. 5 3 is 15. b is equal to 3. b value, I write here. I want to get a value. 6a plus 4 times b equals 24. 6a is equal to 24 minus 12, 12, and a is equal to 2. My solution is not over now. A is equal to 2, b is equal to 3. But a is 1 on x is 2, b is 1 on y, 3. So cross multiplication. 2x equals 1, x is equal to half. 3y is 1 and y is equal to 1 on 3. So this is what has happened actually. We found the values of a and b and we got x and y. And similarly, I do one bit here, and that is 8th bit. Okay, 3.1 first problem, 8th bit. This is something like there is a question in another question. Okay, if you solve half of that, of course, the second half is still remains. I am doing my second question in the sense that 8th bit there. 1 by 3x plus y plus 1 by 3x minus y, and that equals 3 on 4. And 1 by 2 times 3x plus y and minus 1 by 2 times 3x minus y is equal to minus 1 by 8. This is what we need to solve. You can see something which looks similar, like, you are seeing 3x plus y here, 3x plus y here also. You are seeing 3x minus y, here also you see. Therefore, put 3x plus y as, say, a, okay? And 3x plus y wherever you have, you write a. And 3x minus y wherever you have, you can write b. So that makes our work much easier here in the equations given to you. This is 1 by a, 1 by b. I can do another thing which is rather much easier. 1 by 3x plus y if I consider, and that would be even better for me. Like, I just take here 1 by 3x plus y I take as a, and 1 by 3x minus y as, say, b. 1 by 3x plus y if you write a, so this is your simple a, and plus 1 by 3x minus y is your b, so b, and answer is 3 on 4. And let us take here 1 by 3x plus y is a, and of course by 2 is there, it's a by 2, and minus 1 by 3x minus y is b, and b by 2, of course minus b by 2, and your answer is minus 1 on 8. Let us simplify this throughout, and if it's possible, let us do it here also, like, and what I do rather here to, I multiply throughout by 4 to eliminate this 4. Come on, 4a, 4b. This denominator 4 will go, just 3. That's my first equation. I multiply throughout by 8. Okay. So if I multiply here by 8, 2 in 8 4 times, 4a. If I multiply here by 8, 2 in 8 4 times, 4 into minus b, minus 4b, and 8 and 8 will go away, minus 1, because I am multiplying throughout by 8. This is an easy one. These two get cancelled, 4a and 4a, 8a, and 3 minus 1 is 2. I am adding, okay, a is equal to 2 by 8, that is 1 on 4. Let us get the value of b also. A is 1 by 4, b I don't know, I got 3 on 4, okay, 1 by 4 plus b is 3 on 4, 1 quarter plus half is 3 quarters, so it implies b is equal to half, because 1/4 plus half is 3/4. So b value I got. I go straight away there. Come on, 1 by 3x plus y. 1 by 3x plus y is equal to, what is a? 1 on 4. Therefore, 3x plus y is equal to 4. Next step, b is half. What is b? Here is b. Half. 1 by 3x minus y is equal to 1 on 2, 1 half. 3x minus y is equal to 2. This is my second equation. And this I have to solve. Let me write this here. 3x plus y is equal to 4. Add them. 6x, 6. These two get cancelled. X is equal to 1. X is equal to 1, you write here. 3 ones are 3. X value 1. 3 ones are 3. Minus 1 can give you 2. 3 minus 1. So y value also is equal to 1. So that is the solution we are contemplating. Okay. And thank you very much, and that is 3.6, the last exercise of this pair of linear equations in two variables. Thank you very much.